or things like that, was how do you work with slopes? Okay. Slopes. You guys recall what slope was? That's an equation, but slope was what? I heard someone said it was rise over run. Okay, good. So we're talking about what's called slope. Slope is your rise over run. Now, we're talking about this in what's called a coordinate plane. Coordinate planes are your x and y graphs, your xy grids. Which values are the rise? Did I say which value are the y's? Rise. Oh, the what? So your rise is when you go up and down. Your up and down is your y value. The run is your x value. So we write it as what's called the change in y or the change in x. The triangle is the Greek letter delta. Delta, delta, delta. Can I help you, help you, help you? That was a Saturday Night Live sorority skit. Delta, delta, delta. Can I help you, help you, help you? Now, what letter do we use for slopes? Remember slope? Like Joe was just saying a second ago, y equals mx plus b, where m was your slope intercept form, that whole thing. Now, do you guys know why they use the letter m? All right. What does an S look like? Looks like a 5 sometimes. L, what do you use L for? Lines, looks like a 1. What about O? 0. P, do you know what P is used for in math? Probability. E, you guys know what they use E for in math yet? E. E, it's exponential functions. Exponential functions are when you're talking about like compounding interest, appreciation, depreciation, things like that. They use it. It's called exponential function. So then you start going through the alphabet. What are A, B's, and C's used for? More specifically, no, they use A, B, and C for what do they use D for? Distance. E, like I just said. You know what F, G, and H are used for? Functions. F, G, and H are used for functions. Remember that last year? F of X, G of X, H of X? That's what they use F, G's, and H for function notation. Okay. I, you know what I is for? Imaginary. I is an imaginary number. There is such a thing as an imaginary number. It's the square root of -1. Okay. You know what J is used for? Not for juice, but it's used for what's called. It's actually used for something called joint variation. X and Y vary jointly as K. What that means is that you can put together multiple parts. All right. Slope is what we call a direct variation. There's a direct relationship between m to some value x. Joint variation has 2 parts that relate it simply to it. Again, that's something we talked about in Algebra 2. K, no, it's used for a constant. I know that. They also use it for vertical and horizontal shifting. When you have a what's called any of our what are called parent functions in Algebra 2, you have a, let's see here, if I y equals a x minus h 1a squared plus k. That value of k stands for how much it moves vertically, so how much it moves up and down. It's a stupid thing, but I guarantee it's one of those, you see it again, you're like, and that gets you to the L line, and then you're left with the next letter, M. So they kind of went through the whole alphabet and realized, hey, use M. Yes. and has two arms so it can climb, but yet X has two legs so it can run.
That's what I remember.
That's a bad
You know
All right, anyway, I just made all that up, so there you go. You guys, ladies and gentlemen, remember I told you a long time ago, 80% of the things I tell you are true, the other 20 are all made up?
That's like you just gave me a raisin cookie and told me to talk about it.
Intelligent. Guys. So back to this. When we're talking about slopes, ladies and gentlemen, we're talking about sets of ordered pairs. You have to have two ordered pairs to be able to figure out its slope. So when we're talking about change, we're talking about differences. So if we're talking about the difference, usually that means we're talking about subtraction. So the change in y is going to be the second y coordinate, subtract the first. Change in x is going to be your second x coordinate, subtract the first. Again, I know that each and every single one of you guys have done this. It's just a matter of remembering how to set it up. Okay? What's that? Good. Now, how about this? How many types of slopes are there? 4. Very good. There are 4 types of slopes. There are 4 types of slopes, ladies and gentlemen. What is one of them? No, those aren't equations. That's a positive slope.
Negative slope. In between slope.
Neutral, yes. Yeah, I just threw it in neutral, see what happens. So, all right. We have 4 types of slopes. The easy ones are these: positive, negative. We'll talk about the other 2 here in a second. Now, when you're finding slopes, slopes are always some sort of a fraction. Do you guys agree with me on that? Okay. Now, the easiest thing to think of when you're talking about slopes, when you're looking at fractions, is that when you have a slope, if I generically put 2 points on a graph, doesn't matter where they are. When we look at ordered pairs, we're usually looking at them going from left to right. So looking at the point here to here, I have to go up and right. If I move up on a graph, am I moving positive or negative? So I move up is positive, right is positive. So the change in y here is a positive divided by a positive, which is positive, which means the positive slopes go up and right. But think about it in terms of it backwards. If I go down and left, that means I move down and left. What's a negative divided by a negative? Still positive, isn't it? So what we do here is we always talk about our slopes in terms of going up and right for positives, or we go down and right for negatives. Okay? Negative slopes move down and right. Positive slopes move up and right. Moving down and right is the same thing as moving up and left. So I move down, it's negative. I move right, it's positive. So I get a negative over a positive, which is negative. If I move up and left, it's a positive over a negative, which is still negative. It just so happens that more often than not, when we're looking at our slopes, I always taught students to go up or down first and then move to your right. So if it's negative, you move down, go right. If it's positive, you go up, go right. Okay? You know how hard it is to face you and say right's that way? Because it's not right to me. That's weird. Up and right. Up and right, down and right. Don't think of it in words, just think of it as just direction, up and right. Now the other two slopes then are the weird ones. I heard someone say left to right. What kind of lines move left to right? They're all straight knucklehead. Yeah. So if you have a horizontal line, what's the other one? Now back to the idea, ladies and gentlemen. You guys have to bear with me here. I know you've seen this, but I need to get through a bunch of stuff for you guys to be prepared for tomorrow. So more of the same, and it's just going to pick up speed here. So when you have a horizontal line, if you think about what it looks like graphically, you just put a clean one there. You don't have to make a graph, but what I'm saying is, when you have a horizontal line, if I have a horizontal line that's moving left to right, what value of the ordered pairs never changes? 0. The y value. The y value never changes. Horizontal lines, the change in y, if something never changes, what's its change? 0. The change in y in a horizontal line is always 0. The change in x is always going to be some number. So what is 0 always divided by some number? 0. So what happens here is, no matter what, every single horizontal line will always have the same slope. It's always going to be 0. So horizontal lines have a slope of 0. And if it's a horizontal line in terms of an ordered pair, that means that the y values are the same. It means the y values are the same, the x values can be anything. Go back to the other side of thinking about vertical. If horizontal lines all share the same y value, what will vertical lines all share? The x value. So if I go back to my graph, yeah, and then you divide by 0. If I have a vertical line, my change in y is going to be some number, but my change in x will be the same, which is going to be 0. And what happens when you divide by 0? You get 0. You can't do that. Divide by. No, I'll explain why. You can't divide by 0 because it's undefined. What happens is your vertical lines all have a slope of what's called undefined. It's undefined. Now what you're asking is, why can't you? What happens when you get to the value of 0? What I want you to think of is, it's kind of weird to think of this way, but think of infinite, or infinity. Infinity means you can get one number to be even larger than the next, rounded on. You can always add 1 to something. Which means you can also get infinitely closer to something without actually getting there. I'm not touching you. I'm not touching you. You see what I'm saying? It's one of those things. You can always cut something in half. Any number can be cut in half infinitely many times because it gets infinitely smaller. All right? So what happens is that no matter what, as you're approaching 0, you're getting infinitely closer and closer and closer and closer to it, but you'll never get there. So you can't divide by the 0 because if you did, then you've reached what's called, I don't know if you've ever heard this term, an asymptote? Asymptote?
I thought you said
An asymptote, what happens with something that's called an asymptote means you can infinitely get closer closer and closer to it, but you'll never reach it because it's an improbable thing. It's like the idea whenever you have, whenever you see an algebra problem, you probably saw this last year. You had 1 over 2 minus x where x can't equal 2. You ever seen something like that? That's because you have an asymptote 2 because it would be divided by 0. That's why that means. That's why you can't divide it by 0 because it's an asymptote. Because it's an asymptote at that function, it's a discontinuable function. Discontinued at 2. It's a lot of really big words for saying you can't divide by 0. That was a good question. All right. We do a lot of that weird stuff like this now. Relax. Slow, please. Oh, by the way, mixed numbers no longer exist. It's only improper fractions, top heavy, because you can't log the slope of 3 1/2, and you can't log the slope of 7/1. We all really exist. But this is not the time nor the place for mixed number. So if you have your multi-view calculators, that's the other important thing to have here. Because you can create a fraction bar right away. Here's your first x value, first y value, second x, second y. And you just put them together. What's that? And you store it in the calculator. You put it in your calculator exactly the way it's written in your answer. That's all you have to do. That's all I want you to do. Don't try to figure it out any other way. Guys, this is the 8th time as of right now I'm asking you to stop talking. Just stop. So yes, this is the whole reason that we keep pushing these multi-view calculators with you, because of the fraction bar, and that they automatically will simplify the fractions for you, and they will not put it into a mixed number format. Okay? We have plenty of them. If you still have not purchased one, you will really want one. Okay? Otherwise, you'll have to use parentheses and do all that other stuff and know how to simplify your fractions. These calculators are built for this. Okay? Because what you have there is what you're putting in there is 1/2 divided by 2/3. Yes, sir. No, it's not negative. It's positive. It's 2 minus -6. Label. Okay. Now, going with slopes, then you had to be able to write equations. And the most common way that we wrote out equations was slope-intercept form. And if you recall, when I first asked you what's the equation for slope, you guys all said y equals mx plus b. I said, no, that's slope-intercept. So, hey, what's slope-intercept? Now, in terms of these, obviously in this case, what does the M stand for? Slope. And B is your starting point. Well, where do you start on the graph? Your y-intercept. Good. The reason that we always wrote our equations out into what we call the slope-intercept form is because you always get y by itself, and it's a much easier way to graph. Plus, later on, if you start getting into the graphing calculators, there's a button on the graphing calculators that says y equals. So eventually, when we start solving equations, whether they get, polynomials and all that other fun stuff. If you can get y by itself, then you can hit the graphing button and find out a whole bunch of information. Zeros, turning points, max, min, stuff. So if I want to write the equation that has a slope of -3 and a y-intercept of 2, what would it be? Yes, sir. Do you have to? You can, yes. Great question. If you have a slope of -3, that means your slope is going to be down 3, and then what direction? Right 1. If I go down and left, that means I'm going. Okay. So that's the exact same thing as saying 3/1 or -3/1. But do you have to put it over 1? Okay. That was a super easy way for you guys to do things. You've all done that. What became a little bit weirder after we stopped worrying about what we look like in our computer. Let's put it away, Joe. Is when we dealt with this. Do you remember what that was for? Yes, sir. Did you take algebra last year? You learned. Nope. Quadratic formula has a square in it. What do you got? What is it? Oh. No. Point slope form. We don't use it that often. We don't use standard form all that often. There's a time and a place for standard form. It's great for what we call quick graphing, but other than that, I mean, standard form isn't that great anymore. I use it just very seldomly in my Algebra 2 honors class, just because it's a very quick way to get plot points with intercepts. But other than that, it's kind of tedious. Point slope form is for when you know a slope and you have some given ordered pair. So, for example, if I give you a slope of -1/2, and I have an ordered pair of -4 and 3, and I want to write the equation out into slope-intercept form, I start with point slope, and then I rewrite and solve for y. Okay. What happens here is that point slope form is a working version of slope-intercept, because you're not always given your slope, your y-intercept. Sometimes you're just given some ordered pair. So if that's the case, all you have to do is just go through and remember that the ordered pair that you're given is that x sub 1, y sub 1. I keep saying the word x sub 1, y sub 1. You know why they're called sub 1s? Yeah, subscripts. They're called subscripts. If they were up above, they're called superscripts. Yes, sir. Oh, if you know a slope and a point, hence the term point slope form. So it's just a matter of substituting in. Y minus 3, -1/2, x. Ladies, x minus a negative is going to be what? What is always minus a negative? And I always write it like that right away. What's that? From there, you're going to distribute. Great. The generic form always has the y, a slope, and an x. The x sub 1, y sub 1 come from the y. That y and x. Yes, ma'am. So now you distribute. Don't forget, send it to both parts. I guarantee most of you will forget that. And then how do you move the -3? You got it back. Quick question. Do I ever use decimals for slope-intercept form or any of this? No. Will I ever use a decimal? No. Will you ever use a decimal? No. Don't use any decimals. It's kind of difficult to walk a 0.25. I can walk up 1/4. Fractions have their exactly, yeah. Shirt. Apparently I wore the right shirt for today. Yeah. Because you're talking to us, Joe. I'm sorry, man, but there's a lot of it now. All right, one last example. I think we got a little bit. Are we done? All right. We okay? Write the equation. Slope-intercept form off that info, please. Write it. You might be. You're usually going to start out with point slope, but you always finish in slope intercept.
Okay, so
Write the equation of the line into slope intercept form, given that you have a slope and that point. So you have to start with point slope form, and then solve for y. That's summation. Something that's got derivatives stuff. It doesn't have a fraction. 15 bucks, sir. You always want to use this slope. This guy here. There's your x value, negative 6. That's it. Excellent. The y value, so you label. Yes, ma'am. I will suggest it's been about a year or so since you've done these things. Label your values. Seriously, are these guys related? This is just weird. You're doing the same thing he is yesterday. Do this. Hey guys, suggestion, because I know that where things are getting messed up. When you have these problems, it does not say that that's a y-intercept. It just says it's a sum ordered pair, which means you're not going to use slope-intercept form. That means you have a point and a slope. So you're going to use your point slope formula and fill in the blanks. Remember, that ordered pair is your x sub 1, y sub 1, was direct substitution. Y minus 4 is 1/3 x minus a negative 6. Minus negative 6 is plus 6. Good. Yeah. Now you have to solve for y. Now is when you distribute and then once plus 6 on that is plus 2. And then how do I move the negative 4? Now I'm in slope intercept form. I had to start with the point slope to figure out what is it going to look like when I'm done. Because it is so much easier now to graph once I get to that in terms of that. Because I know my one. These are the kind of things that we're going to be doing over the course of the next week. We're going to be writing tons and tons and tons of equations. It's a lot of this. It is kind of like a mad dash through everything that you forgot in Algebra 1. Okay, it really is. If you look on the calendar from as of now, I have posted on there it says a 3.7, 3.8 new book worksheet. Now, we're going to use that same worksheet over the course of the next few days. It's not like we're doing all of it. I get that right here. I've already posted some problems about it. I have a dozen problems for you. It's just quick writing equations. Okay? Finding slopes, writing equations. So when you pull it up on your book or on your Chromebook, phone or whatever, you will see set problems. Don't worry about graphs. You're finding the slopes of those four. You're writing an equation given the slope and a y-intercept. And then the last one, point and slope. So you have to write these point and slope. So it's just a quick 12 problems. That should not take forever. Tomorrow what we'll start with is write equations given 2 points. We'll go with 2 points, and then we'll probably go with parallels and perpendiculars tomorrow. And then on Friday we'll talk about graphing and going through all that. By the time we get through all that harder algebra stuff, the graphing's the easier. Okay? That's what I have for you guys for this evening. I know I might have a minute or two, but at least you can pull it up and screenshot if you have to do or okay? Don't look so excited. Yes, ma'am. Don't know off the top of my head.